Welcome back, everyone. Ready to dive into something pretty wild.
Always up for a challenge.
All right, so you sent over some sources about this alternative to the Big Bang theory,
Right.
and wow,
Yeah.
this is really making me rethink things. Instead of this like super hot explosive start,
Yeah.
it's saying the universe began cold.
Totally flips the script, huh?
Yeah, it really does.
It suggests that the universe isn't expanding because of this big initial push,
Right.
but because of these constant interactions between positive and negative charges.
These charge imbalances, yeah. And what's really interesting is that the sources suggest we can actually use water to kind of wrap our heads around this.
Yeah, it's pretty amazing. It takes these huge cosmic concepts
Right.
and grounds them in something that we all experience every day,
Totally.
Think about the basic properties of water. It's polar, right? Meaning it has a positive and a negative end.
Right, right. And water molecules are always structuring themselves too.
Yeah, in these really intricate ways.
Yeah.
And then when water freezes, it does something kind of unique.
Okay.
It expands
Yeah.
and takes up more space, but it also releases heat in the process.
So it's like it's trying to maintain balance.
Right.
It's expanding outward,
Yeah.
but also releasing energy to keep things in check.
Exactly.
Could that be like a tiny mirror of what's happening on a cosmic scale?
That's what the sources are suggesting, yeah.
Yeah.
They're saying the universe could be governed by a very similar principle. These charge differentials are driving expansion.
Right.
But there's also this balancing force
Okay.
that maintains equilibrium through these energy shifts.
So instead of this like sudden hot explosion, it's more like the universe started cold.
Yeah.
And is slowly expanding and evolving based on these charge interactions.
Mhm.
I'm already like rethinking everything I thought I knew about the Big Bang.
Yeah.
But okay, what about the cosmic microwave background?
Right.
That's supposed to be one of the strongest pieces of evidence supporting the Big Bang.
Right. Yeah, the CMB is often seen as the afterglow of the Big Bang. But the sources argue that even that could be explained differently.
Okay.
They say the CMB could be the result of these charge imbalances.
Okay.
Specifically, something called charge-induced polarization.
Charge-induced polarization.
Yeah.
What does that even mean?
Okay, so think about it like this.
Okay.
You've got these charges spread throughout the entire universe.
Okay.
As they interact and shift, they create these patterns in the very fabric of space-time.
Oh, okay.
Think of it like tiny magnets all aligning themselves and influencing the structure of the universe.
Okay.
Those patterns might be what we're actually seeing when we observe the CMB.
So that faint afterglow we thought was from the heat of the Big Bang. It could actually be a signature of these charge imbalances.
That's the idea, yeah.
Wow. That's a pretty radical way to reinterpret things.
Yeah.
And I remember reading in one of the sources about something called the fine structure constant.
Right.
How does that fit into all of this?
So the fine structure constant is often represented by the Greek letter alpha. It basically governs the strength of electromagnetic interactions.
Okay.
In traditional physics, it's considered this fixed value.
But not in this model.
Exactly. The sources are proposing that the fine structure constant might not be constant at all.
Wow.
They're saying it could actually change over time and space,
Yeah.
and these changes are influenced by, you guessed it, charge imbalances.
So this number that dictates how particles interact with each other,
Yeah.
it could actually be in constant flux.
It's like finding out that the rules of the game are always changing.
Yeah, exactly.
So think about it this way. If the fine structure constant is dynamic, then the way things interact in one part of the universe
Right.
might be completely different from how they interact in another part, or even how they interacted billions of years ago.
Yeah.
And that would have huge implications for, well, everything.
It's like rewriting the laws of physics.
Pretty much.
This is a lot to process.
We're just getting started.
Oh, boy.
But before we get too far ahead of ourselves, let's take a step back and consider how this model explains something as fundamental as the formation of galaxies.
Okay.
In the Big Bang theory, gravity is the main force pulling matter together.
Right.
But this alternative model, it proposes an additional force at play,
Okay.
charge differentials.
So not just gravity, but the interplay of positive and negative charges is what's shaping the universe as we know it.
Precisely. Imagine these charge imbalances influencing how matter clumps together, how it attracts or repels other matter.
Okay.
This could be another key factor driving the formation of those beautiful spiral galaxies
Right.
and vast cosmic structures we observe.
Wow. So we've talked about how this charge-driven model could explain like the expansion of the universe and the formation of galaxies and all that. But what about something like dark matter?
Okay.
That's a pretty big mystery in
Yeah.
the current understanding of the universe.
It really is. And it's one of the areas where this alternative model gets super interesting. So remember, dark matter was proposed to explain why galaxies seem to have like more gravity than we can account for based on just the visible matter alone.
Right.
It's this invisible stuff that supposedly makes up a big chunk of the universe's mass.
Yeah, the cosmic glue holding everything together.
Right.
But we've never actually like directly detected it.
Right.
So what does this model say about it?
Well, the sources suggest that maybe dark matter doesn't actually exist at
So
all.
wait, really? Are you saying dark matter could just be like a cosmic illusion?
It's a bold claim, for sure.
Yeah.
But the idea is that the gravitational effects we attribute to dark matter could actually be explained by this interplay of charges and that dynamic sign structure constant we were talking about.
Okay, but how could charge imbalances create the illusion of extra gravity?
Remember how we talked about how the fine structure constant, the one that governs electromagnetic interactions, it might not be constant after all.
Right.
Right.
So if it changes over time and space, it could totally affect how particles attract and repel each other.
Oh, so you're saying these variations in the fine structure constant could create like regions of stronger or weaker electromagnetic forces.
Exactly.
And that could mimic the gravitational effects we attribute to dark matter.
Yeah, that's the idea.
Huh. That's a pretty elegant way to explain it away.
Right.
But, okay, what about dark energy then?
Okay.
That's the mysterious force that's supposed to be responsible for the accelerated expansion of the universe.
Right.
Does this model have an explanation for that too?
It does, and it kind of builds on the same principles we've been talking about.
Okay.
So instead of bringing in dark energy as like a separate force,
Yeah.
the sources are suggesting that the accelerated expansion we observe could be a direct result of these charge imbalances and the dynamic fine structure constant.
So we're talking about a universe where like the fundamental forces are in constant flux.
Yeah, pretty much. Driving expansion not through some mysterious dark energy, but through these ever-changing interactions of charges.
Exactly.
This is incredible. We've gone from reinterpreting the cosmic microwave background to potentially like getting rid of dark matter and dark energy altogether.
It's a whole new way of looking at the universe.
It really is. It's like we've been handed this entirely new set of blueprints.
Yeah.
And what's even more exciting is you mentioned these sources offer a way to like test these ideas.
Right.
Remember those simple experiments with water?
Yeah, those could be key.
The ones with structured water and electric fields? Ice crystal growth?
Yeah.
And the evaporation of water under electromagnetic fields.
Right.
How could those possibly tell us anything about the universe on such a grand scale?
Think of it this way. Water is incredibly sensitive to any changes in electromagnetic fields.
Okay.
Its behavior can change dramatically depending on the strength and orientation of those fields.
Yeah.
So by carefully studying how water responds in these experiments, we might gain insights into how charge imbalances and a dynamic fine structure constant are influencing things on a much larger scale.
So it's like using a droplet of water to peer into the heart of the cosmos.
Kind of, yeah.
Yeah.
It's a simple but elegant approach.
I love it.
And what if these experiments actually reveal patterns
Yeah.
that perfectly align with the predictions of this charge-based model?
That would be huge, wouldn't it?
It would be a huge piece of evidence supporting this new view of the universe.
Yeah.
Yeah.
This is all so mind-boggling.
It is.
It really makes you wonder what other assumptions we might need to re-examine.
Exactly. This is a call to question everything.
Yeah.
Approach the universe with a sense of wonder and curiosity,
Right.
and be open to the possibility that even our most cherished scientific models might be wrong.
I feel like my brain is doing backflips just trying to wrap itself around all this.
I know, it's a lot.
But before we get too lost in the cosmic weeds here, let's bring it back down to Earth for a second.
Go.
What are the implications of this model for, like, life itself?
That's a big one.
It is.
And it's one that the sources don't shy away from at all.
Okay.
So if the universe is driven by this interplay of charges, always trying to find balance and equilibrium, could that principle extend to life itself?
You're saying life could be like another manifestation of this cosmic dance of charges.
What if we're not just random accidents, but somehow woven into this fabric of this electromagnetic universe?
Yeah, instead of feeling small and insignificant in this vast cosmos,
Right.
we'd be intimately connected to the universe, like integral parts of its grand design.
Exactly.
Wow.
And if the universe is constantly seeking balance, maybe we can take inspiration from that.
Yeah.
Strive for harmony in our own lives.
Yeah.
Our relationships, our communities, our connection with nature.
That's beautiful.
It is.
But I have to ask, if this charge-based model turns out to be correct, like what happens to the Big Bang Theory then?
That's a good question.
Does it just fade away into the cosmic background?
Well, scientific theories are always being refined and updated as new evidence comes up.
Right.
So if this alternative model gains enough support,
Yeah.
it could definitely lead to like a paradigm shift in cosmology.
Hmm.
It might not totally replace the Big Bang Theory, but it could offer like a more comprehensive understanding of how it all began and evolved.
It's like we're witnessing a revolution
It really is.
in our understanding of the cosmos.
Yeah.
And to think it all started with this deep dive into some pretty unconventional sources.
Yeah.
And just being willing to question everything we thought we knew.
It's amazing, right?
That's the beauty of science, I guess.
Absolutely.
It's a never-ending journey of exploration and discovery.
Couldn't have said it better myself.
We've been on quite the journey, haven't we? Exploring this whole idea of a universe that's born cold and shaped by charges.
Yeah, it's a real mind bender. It challenges a lot of assumptions.
Yeah. Before we wrap up, though, I want to go back to something you said earlier about how this charge-based model could have like implications for how we think about life itself.
Oh, right. If the universe is operating on this principle of charge equilibrium,
Yeah.
this constant back and forth between positive and negative charges,
Yeah.
could that same principle apply to, well, life?
So life might not just be this random thing that happened.
Right.
It could be an actual part of this like cosmic dance of charges.
Yeah, like imagine life not as an accident, but as this emergent property of this fundamental principle of charge balance. We could be like intricately woven into the very fabric of the universe.
Yeah. Expressions of the same forces that create stars and galaxies and everything.
Exactly.
That's pretty wild. It makes you feel a lot more connected to everything,
It's humbling.
Yeah. And, if the universe is always searching for balance, maybe we can learn something from that. Maybe we should strive for that harmony in our own lives, too. In our relationships and communities, even our connection with nature.
That's a beautiful thought.
Yeah. It's a nice reminder that, even as we're exploring the vastness of space and time, we're also exploring the mysteries within ourselves.
Oh, absolutely.
Yeah.
And who knows, maybe those simple experiments with water we talked about
Right.
could offer us some insight into these connections between, the microcosm and the macrocosm.
Yeah. It's amazing to think something as simple as watching water in an electric field could unlock these big secrets about the universe and our place in it.
Yeah, it just goes to show that exploration doesn't always require fancy equipment or these complex theories.
Right.
Sometimes the biggest insights come from the simplest observations.
Well, this has been an incredible deep dive. We've covered so much, reinterpreting the cosmic microwave background, rethinking dark matter and dark energy, even exploring what this model could mean for life itself.
It's a lot to think about. It's a good reminder that the universe is full of mysteries.
It really is.
And our understanding is always changing.
I feel like I started this deep dive with a bunch of questions, and now I have even more.
That's a good thing.
It is.
Yeah. Curiosity is the engine of progress. It's what pushes us to explore and question and just keep searching for those answers, even when the answers lead to more questions.
That's a good point. I'm definitely inspired to keep learning more. This conversation is going to stick with me for a while.
Mine too. It's been a pleasure diving into all this with you.
Thanks for joining us on this journey, everyone. Until next time, keep questioning, keep exploring, and keep looking up at the stars with a sense of wonder.
And remember, the universe may be full of mysteries, but the pursuit of knowledge, that's what lights the way forward.